Hello student, welcome back. We are going to start today's session. It is lecture 6, module 3, microcontroller and embedded system. Shongita Roy, assistant professor, electronics and communication engineering department, Narula Institute of Technology. 8051 assembly language programming tools. In the previous classes, we have successively completed in the 5 classes 8051 microcontroller assembly language programming, the structure of 8051 assembly language, example programs, time delay calculation, IO programming, call instruction, IO port programming in 8051, bit manipulation, input output programming in 8051, addressing of 8051, and today's lecture 6. Accessibility of memory by using addressing modes in 8051. The register direct or indirect addressing modes can be used to access data stored in RAM or registers of the 8051 microcontroller. Direct addressing mode. RAM in the 8051 has 128 bytes and has addresses 0027FH. RAM location 00 to 1FH are assigned to the register banks and stack. RAM location 20 to 2FH are set aside as bit addressable space to save single bit data. RAM location 30 to 7FH are available as a place to save byte-sized data. The entire 128 bytes of RAM can be accessed using direct addressing mode. The direct address is most often used to access RAM location 30 to 7FH. There is no other or alternate name for other RAM locations except the register bank's location are accessed by the register name of R0 to R7. But there are no such name for other RAM location. The data is in a RAM memory location whose address is known, and this address is given as a part of the instruction. In the case of direct address mode, contrast this with the immediate addressing mode in which the operand itself is provided with the instruction. The hash sign distinguishes between the two modes. Move R010H, save the content of RAM location 40H in R0. Move 55HA, save the contents of accumulator ACC in RAM location 55H. Move R37FH, save the contents of RAM location 7FH to R3. RAM locations 0 to 7H are allocated to bank 0 register R0 to R7. These registers can be accessed in two ways. Move A3, 3, the same as the instruction given below. Move A, R3, copy the value R3 into accumulator A. Move A, of R3 into accumulator A. Move A, 2 is same as the instruction given below. Move A, R2, copy value of R2 into accumulator A. Move A, 0 is same as the instruction given below. Move A, R0, copy value of R0 into above example can make understand the importance of hash sign in a R3 equal to 2. Yes. Okay. So move B comma R3, copy R3 to accumulator B, that is to B is equal to R2 R. Okay, sorry. MOV R6 comma R2, copy the value of R2 to R6. This instruction, so copy R2 to R6. This instruction is invalid since move R6 R2 is invalid. It is easier to use the name R0 R7 than their memory address RAM location 30H to 7FH can be accessed in any another way. Then their access, they have no names. So addresses register. B register, A register, PSW register and DPTR register, as discussed in previous section, also have addresses. These register are special function register or SFR. There are many other special function register widely used. The special function register have their names through which SPF can be accessed by their names or by their addresses. Register A has address EOH and register B has addresses FOH. The SFR table is listed below. Special function register SFR addresses. Accumulator symbol is SEC. B register symbol is B. Program status word symbol is PSW. Stack pointer SP. DPTR data pointer 2 byte. DPL data pointer low byte. DPH data pointer high byte. PO port 0, P1 port 1, P2 port 2, P3 port 3, and corresponding addresses are 0 EOH, 0 FOH, 0 D0H, 81H. Then DPR has no address, DPL 82H, DPH 83H, PO 80H, P1 90H, P2 0A0H, P3 0B0H. Corresponding byte or bit addressable. First one is bit addressable, second one is bit addressable, then it is byte addressable, byte addressable, and PO is bit addressable, P3 also bit addressable. IP interrupt priority control, IE interrupt enable control, TMOD timer or counter mode control, TCON timer or counter control, T2CON timer or counter to control, T2 mod timer or counter mode control, TH0 timer or counter 0 high byte, TL0 timer or counter 0 low byte, TH1 timer or counter 1 high byte, TL1 timer or counter 1 low byte, TH2 timer or counter to high byte, TL2 timer or counter to low byte. Corresponding addresses 0B8H, 0A8H, 89H, 88H, 0C8H, 0C9H, 8CH, 8AH, 8B, 8DH, 8BH, 0CDH, 0CCH, and corresponding bit addressable, bit addressable, byte addressable. TCON is bit addressable, T2CON is bit addressable, T2 mod is byte addressable, TH0, TL0 to TL2 is byte addressable. RCA P2H timer or counter to capture register high byte, RCA P2L timer or counter to capture register low byte, SCON serial control register, SBUF serial data buffer register, PCON power control, and corresponding address is 0CBH, 0CAH, 98H, 99H, 87H. First one is byte addressable, then all next one is byte addressable, SCON is bit addressable, SBUF is byte addressable, PCON is byte addressable. Special function register SFR has addresses between 80H and FFH. The addresses 00 to 7FH are addresses of RAM memory inside the 8051. There are some unused location between 80H to FFH. These are reserved and must not be used by 8051 programmer. The pair of instruction given below are the same thing. Move 0E0H, hash AAH is the same as the instruction given below. Move A, hash AAH. Load the value of AAH into the accumulator. Move 0F0H, hash 24H is same as the instruction given below. Move B, hash 24H. Move 0E0H, hash R1 is same as that of move A, hash R1. Move 0F0H, hash R7, move B, R7. They are the same meaning. Example 1. Let's write a code to send 55H to port 2 and port 3 by using their original name and by using their addresses. By using their name. Move A, hash 55H, load 55H into accumulator register A. Move P2, A, send 55H value to port 2. Move B3, A, send 55H value to port 3. Move 0E0H, hash 55H, load 55H into accumulator A, 0E0H accumulator addresses, move 0A0H, 0E0H, send 55H value to port 2, 0A0H to port 2 address. Move 0B0H, 0E0H, send 55H value to port 3. 0B0 is the support. Access the data ROM space of 8085 indexed addressing mode is used. The instruction format for this mode will be move CA @ A plus DPTR. The 16-bit register DPTR and register A are used to form the address of data element stored in on-chip ROM. The data elements are stored in the program or code space ROM of the 8051. The instruction move C will be used instead of MOV. The C in move C instruction mean code. The instruction move CA @ A plus DPTR, contents of A are added to the 16-bit register DPTR to form the 16-bit address of data which is to be needed. Example 1. The word Canada is used to burn into ROM location starting at 300H, and that program is burned into ROM location starting at 0. Let's analyze the program where Canada is stored after this program is run. org000H burn into ROM starting at 0. Move DPTR, hash 300H. Data pointer DPTR is equal to 300H lookup table address. CLRA, clear accumulator A. Move CA, @ A plus DPTR. Get the character from code space. Move R0, A. Save it in register R0. INC DPTR is incremented by 1. So now the location from 300 to 301 pointing to the next character. CLRA, clear accumulator A. Move CA, @ A plus DPTR. Get the next character from code space. Move R1, A. Set the accumulator content to register 1. INC DPTR is incremented by 1, so the location from 301 to 302 pointing to the next character. CLRA, clear accumulator A. Move C A, @ A plus DPTR. Get the next character from code space. Move R2, A. Save it to register R2. INC DPTR is again incremented 302 to 303. Pointing in the next character. CLRA, clear accumulator A. Move C, A @ A plus DPTR. Get the next character from code space. Move R3, A. Save it in register R3. INC DPTR again incremented from 303 to 304 and pointing the next character. CLRA, clear accumulator content A. Move CA, A plus DPTR. Get the next character from code space. Therefore, now the pointer is 305. Move R4, A. Accumulator content is stored.